the construction of a Makino spindle oil cooler. This is the original control board of a Makino oil cooler. There was a huge fire initiated by the hydraulic main contactor, and the whole oil controller burned out. So what I did was install a Step 7 300 PLC on it, a 315C CPU, and I had to rewire all the I/O, the interface between the Simatic PNC to the custom-made controller by Makino. So here is the hardware configuration of the CPU 315 plus 32 inputs and 32 outputs, and I constructed the ladder logic based on what I know. So I'm using every signal of the interface, and this is the reason why the original hydraulic unit got damaged. These are the original pumps from the Makinos. None of them works really. So I installed another hydraulic unit, and this is why output byte Y2, and this byte is interfacing with the Makino oil controller to indicate that the spindle is running. So every time you turn on the spindle, some bits of this byte turn on. Byte Y2.3, that bit turns on every time I set an M3 command on the spindle. So I'm using that byte to interface with the PLC, and this is compared to 0. So if the byte is different than 0, it means the spindle is running. So the cooling unit here that is triggered by that contactor will switch on, and that will cool down the oil, because the spindle is pretty sensitive to heating, so it needs to be lubricated and cooled using oil. So every time the spindle turns on, the refrigerant circuit will turn on, and this I'm going to show you here the schematic of the oil-matic. Here in the green circuit you can see the refrigerant circuit, and here on the pink circuit, that's the oil that's circulating between the pump and the heat exchanger, and then fed into the spindle. So there are two solenoid valves that turn on alternative. One turns on, the other turns off, and thus here is the hydraulic unit, a new hydraulic unit that I had to install on the Makino, because the original unit doesn't want to work. And this is now an HMI. You can see a red dot under a pump. That's because I intentionally triggered an overload relay, and the dots underneath every pump indicates that the thermal protection of the motor switched on. So I'm going to, right now the oil cooler is not working because an overload relay was tripped. So I'm going to reset it, and once it's reset, you can see now that the oil cooler now is working. And here on the Simatic panel, the alarm is gone, and the status on the bottom right indicates that the oil-matic is running properly. But right now the spindle is not spinning, so I'm going to reset the alarm on the Makino. That's because I tripped the overload relay, one of the pumps. The automatic alarm switched on, so now I reset that alarm. Going back to MDI, I'm going to type a S1000 RPM, and then turn the spindle clockwise. There. So this will signal to the oil-matic that it's time to switch on the refrigerant, the compressor, and the fans so the oil can be cooled down, because the spindle needs to be cooled down. All the power is dissipated using oil. You can see the valve switching on and off. These valves will pour oil back to the tank. This is what I've done in the past 2 weeks. Thanks for watching.